They don't just work with data, they understand it. With a sharp eye for structure and a passion for solving many problems, Pradeep has been behind some very serious smart data systems. From wrangling massive data sets to building clean, scalable pipelines, they are the kind of person who sees pattern where others see noise. Good data engineering isn't just about tech, it's about building trust in what the data says. Tune in as we talk about the world of data, what it takes to be a great engineer, and why clean data might just be the quiet hero of every modern product.
Hey there, everyone. Welcome to Espresso Minds podcast. We are here to make the future a little less scary with the great conversations we are going to have about AI to VR and everything in between. Let's brew up some great coffee and have some great conversations. Welcome all. With this, let me introduce you to our guest today is Pradeep Pai, a very, very dear friend of ours from college days, a mechanical engineer, but now a data engineer. A huge gap of domain and industry. So over to you, Pradeep. Thank you so much for coming, man. Welcome to the
Yeah.
podcast.
Thank you, Pramod. Thanks, Tejas, for having
Yeah.
me here.
So on that, as Pramod mentioned, like all of us are mechanical engineers from where we started. So just in terms of obviously out of that, Pramod and Pradeep, you guys have gone on to IT and you've gone on to computers, like you've gone on to this field of work, which is so significantly different from mechanical engineering, you can say. Obviously, I've remained in mechanical engineering where my experience is more about interacting with objects and like interacting with physical objects is more my job. So Pradeep, so how's your journey been since you graduated from your mechanical engineering degree, and how it's going now? Can you just give us a big rundown of these things?
Sure. I mean,
Yeah.
question is pretty simple, but the answer is a bit long. But let me try to be as brief as possible. One thing was that the 4 years of mechanical, which I did do, I never felt like there was something which would scratch my brain or where I felt like I had to get the answer for. It was always that the question was there, but I was never motivated to find the answer. So towards the end of mechanical, I always knew that if I'm not motivated to find the answer under pressure with no incentive for money, even if there is a money incentive, I would most probably do my bare minimum, right?
Yeah.
So that's where I realized there's some kind of, I mean, it's just not for me is what I realized over there. And of course, at the same time, coincidentally, the job market was not that great at the year of my graduation, 2019 in India, for mechanical folks. And after hopping on for job interviews and so on, I instantly came across Infosys, who was happy to hire anyone and everyone. Totally grateful to them for that. And somehow I cleared the aptitude, got in. Never thought I would love it. For the first time in life, I did programming and I enjoyed it. Like for the first time, I felt like this is an answer I have to get. It was a very simple thing, right? They're just teaching programming and you're just trying to find the number of diamonds that are there, solve for X. Simple thing. But knowing that I wrote the code and the code is actually giving me something that kind of inspired me to think, okay, maybe this is the right path for me, right? Even at that point, also, it's just 1 or 2 months into your career, into your training. Also, you don't really know whether this is it for you. But that's where I got that inclination. Maybe it is, right? That's where the thirst started.
Yeah.
And of course, the first company, as such, wasn't enough for me, and I knew that before I settled down, it would be really great if I could explore my opportunities, right? As such, you don't get to choose where you end up, right? In companies like Infosys, Wipro, one of your rich companies. However, the demand is you're just put somewhere. And luckily for me, I was put into data engineering, data analysis.
Okay.
But once again, I had this thing that what if I'm liking it because that's all I know, right? Everything else is out of scope for me. And I felt unless I venture out and know more about the other things, like maybe backend or machine learning, data analysis, whatever it is, I cannot really say that I love data engineering. It's just that it's all that I know. So that's where the next 2-3 years, my journey was about going across the board into backend engineering, data analysis, business intelligence, creating Tableau reports, and so on. Till finally, I realized data engineering is it?
But just on that, so just before you took that plunge into actually taking up data engineering, did you ever have like sort of second thoughts in terms of where you could put, or at that point, did you have an idea in your head, say, or where did you want to be at that point before you took that sort of chance of doing data engineering?
There was no option, right? That's the whole point of it.
Okay.
In
Okay.
those,
Okay.
the situation and circumstances were such that that was the best path for me at the time.
I second that.
But
I second that.
yeah, I mean, at the end of the day, we all do it for money, right? The money is
Yes.
necessary, and you need sustenance and all that. But it's really good when the thing that you do for sustenance becomes a thing that you do love. So
Okay.
that's
Okay.
when, after coming across the whole circle, after getting into backend and stuff, I realized that my first love was data engineering, and that's where I
Okay.
want to continue on. Yeah, finally did my final switch into a company where I knew that they had an amazing opportunity for data engineering and the growth was good and everything, and yeah, got back into it. So yeah.
But in addition to the hustle culture, especially with mechanical engineering or say physical engineering, chemical engineering, mechanical engineering, right? So certain concepts remain the same in terms of like most industries, they do innovate and try to do things, but the base concepts kind of remain the same. With especially with software engineering and IT, it's constantly changing. So I feel like that hustle time that you're mentioning about, it's probably required for you because you need to update yourself in terms of what's out there, and without that probably you become, because I feel like I don't know if this is true or not, as soon as if you become obsolete, you're unwanted, like in some sense. Yeah.
That depends. I mean,
Okay.
so that's the whole thing, right? I mean, if you do not keep learning, then there will be a stagnancy.
Yeah.
In terms of, I mean, you have two career paths. You can either at one point change over to the management. Once again, or you're not learning about stuff, but then you just become a better negotiator and everything, right? So once again, you're learning in one way or the other.
Yeah.
So
Okay.
it has to go on. I mean, unless I guess it was in our like parents like generation where
Yeah.
people would stop learning, they would be at the same job for like a couple of years before a
Yeah.
promotion comes by. But right now, people, I mean, we want a promotion in 3 years, right? We can't just take it as such. At least in the initial years, 3 years is manageable. Of course, if you go to a higher level, then you'll have to wait for a couple of years before a position opens up. But I guess that's the whole point of it. So yeah.
So
So
adding to what Pradeep said, even if you go into management or become a negotiator, also even at that stage, also you are supposed to know the technologies that is running around. So that if you're doing a sales pitch, for example, if you are in the management, upper management, you become a salesperson. It's by fault. Even if you're in operations, if you're in HR, you become like a salesperson also. So you're
Yeah.
supposed to know the latest technologies and latest upgrades that are happening. So learning never stops, no matter where you are. Even if you are in IT field, if you're in an engineering field, wherever. I have my father who's learning Tally. He just got into administration and finance for one of the company, and he's learning Tally at the age of 63. I have a director in my company who just got certified to Teradata. He's a senior director in our company, and he just got certified in Teradata. So that learning never stops, and that's something that I've learned from my current company, is that by no matter what happens, you can be absolute for some time, but the point is that the nature is that you need to start upgrading yourself. You can't just be laid back and say like, okay, fine. You remember how our parents used to like, beta ek baar job lag gaya, then you're good to go. Your life is settled. That is absolutely not the case. To everyone who's hearing this, this is absolutely not the case. You have to hustle till
Biggest
the end of
scam
your
of
breath.
life.
Biggest scam anyone has said this.
Finish engineering.
No, but
After
I
you
feel
finish 10th, it's 12th. After 12th, it's engineering. After
exactly.
engineering, first job. Are first job lag gaya na beta? 2 saal, it's done, no? Now do something and go to the next job.
Oh man, the biggest scam of like, oh, if you finish 10th standard exam, your life is set. Oh my God. Okay, on this note, I want to understand in terms of Pradeep. So obviously, so the whole inspiration for this episode, okay, at least my inspiration for this episode is actually towards the end of last year, right? So I was say, obviously, you know how Spotify collects your data in terms of your music preferences and these things, right? So that Spotify mash that it came out, I was really fascinated by, I took some time. I was going through my sort of like the whole list that it produced. I was really fascinated by the amount of data it's collected, the way it's analyzed, and the way it's presented to me as well, which is like I found that really fascinating. So I want to understand in from your perspective. So what is your role in this whole, like, for example, it's data collection, data analysis, data. What is your role exactly? If you can just give us a complete breakdown of your role in this whole process with an example, hope if you can.
Yeah, I mean, we can take any generic
Okay.
example. In my company, I work in the clickstream team. So just a generic, almost every big company has any e-commerce company. So far, we'll have a clickstream team. Clickstream is nothing but it is a team whose sole responsibility is to understand what the user does in what way, right? Any interaction that you do, which can be, let's say, Spotify, whenever you play something, you pause something, you do a search, what should come in the search, and when that does come, so that's based on your models, ML models and stuff. When that does come in the Spotify, you do click on something, everything gets registered, right? Everything is tallied, and every device has its own identity, which is of course recognized. Every account has its own username, which is also recognized, and there will be one such team called the clickstream team, which will be in charge of all this to keep this data, to modify the data as needed, and to have a really good structured way so that the data is not duplicated. We don't have any loss of data. And at the same time, multiple teams, right? So imagine you have 80 million users around the world who use Spotify, right? And
Yeah.
I am a team who knows, or rather, who has the data of each and every user that's out there. What songs he played, what songs, for how long he played, how many times did he play, is it a song which he played for 15 seconds and then skipped forward, right? And each one of these gives you good insights, right? Because then if you tag a song based on the genre, and if there is
Hmm.
some kind of an analysis or insight that you particularly like to skip songs of a particular genre, then it means
Hmm.
that genre is not something which you like, right? And that's where you have a lot of ML, machine learning folks and like data scientist folks who create all these insights using their models and stuff. And so yeah, that's what Clickstream does basically.
Yeah.
So
Okay.
and once again, when you use any application or website, it's nothing but backend, right? Backend, front end. You'll have a server, you'll have a client. You're basically putting in a request in some type of event, and it's just collection of that event which becomes our raw data. And then how we manage that data, that is where data engineering comes. It's not our job to get the insights, but the data itself is so huge
Hmm.
that it's not really possible to do it in conventional terms, and you have to use specialized tools to process and store the data.
Can you give a sense of how much data you're essentially dealing with? For example, someone visiting an average website, for that matter, how much data is someone generating just by visiting a website?
I mean, it's not much. It can be somewhere around 200 to 300 MB, right?
Okay.
Yeah. I mean, any traditional browser, if you use YouTube itself only, you're basically generating, at least 0.5 GB of data as
Okay.
such.
Okay. Okay.
You
Okay.
use Spotify, if you use just social media of any kind, you're basically generating around 100 to 200. You're consuming or even transacting as uploading, whatever it might be, 200 to 300 MB of data. At the same time, that's just overall. But when you call about events, it's maybe just 5 MB, 3 MB,
Okay.
right? Just the
Okay.
events. We just want to know the information. Textual basis, there is no images or nothing. It's just like 2 or 3 MB. But the whole problem is the scale of people, right? When I'm talking
Yeah.
about these companies, they are giants in their industry. Spotify for music, you have, Netflix for streaming, you have Expedia for travel, so each one of these are giants in their sectors. So it may be small data from each person, but then the number of consumers or the customers that they do
Yeah.
address, that increases it considerably, right? So
Yeah.
So with that, for example, if a particular person is logging into a website and he or she is just scrolling around and stuff, and the data is getting collected, as you said. So what does your role come in once you get the data? How do you streamline it? How do you automate it? And what is your role? How do you do that? Can you just give us a brief on it?
So yeah, I mean, when you talk about website and data collection over there, you're basically mentioning about clickstream data, right? So in a very general sense, it's nothing but first you have to do is the data extraction. So whenever you interact with the API, so as to say the SDK package or so for that particular website, whenever that happens, an event is generated. We call them as producers, and it generally goes into a pub sub, right? A streaming pipeline basically where live events go in. So there is no delay as such, right? Maybe of less than a second or maybe two. Generally between when your event or your like when you do the click as such from that to when it lands in the table, right? A particular service which continuously listens to these events, it transforms the data, rather basically cleans the data up, so and then it'll land it somewhere in either a file system or some kind of a table and so on. From there onwards, or rather that part of listening, it's where data engineering starts. That's where the backend engineering gets done, right? The backend engineers, what they have to do is they have to provide you the data for your website and everything. And any interaction that happens, they have to send a copy to like this clickstream team, right? So that we know exactly what's happening. Why? Because the backend engineering team, they generally work with live data, right? Live interactions. But now to know historical things, to know things at scale, that's where the data engineering team comes in. What is our job? Our job is then further, okay, we have done the data collection. It's the raw data. How do we structure the data? How do we make sense of the data? We do not want insights, but then if there are 5 fields and we know where the data is coming from, which the data analyst will not know, we know what kind of data it is, then we will put all those data into a different kind of a structure or a bucket, maybe a different table altogether, or maybe we'll have a substructure. So like a parent field with a child field and so on, saying that, hey, this is maybe, let's say, Spotify will have a field called as genres, right? And a particular song can like belong to different genres, not just one. So you will need to kind of showcase it in multiple ways and so on, right? So that's what the data engineering team will do. At the same time, they'll document everything so that tomorrow, if someone wants to read this data, how do you read it? What is the best way to read it? And now to say it, there are multiple things that we have to take into consideration. Definitely with if someone's using our data, can they get this data in the shortest time possible? Taking the case of Spotify, you can take the case of Facebook, however it might be. But basically, these are giants that are there in the industry from years altogether. You have 12 years worth of data. If an analyst wants the data of only like one day, then it's not feasible to read 12 years worth of data for that one day's analysis. That's where we have to put in optimization strategies like partitioning and so on, where we make packets of the data and keep it separately in storage, so that if someone wants 1 day of data, they'll specifically take only that, and the rest, whatever X amount of data, will be untouched. So the data processing time increases. But thinking about all these strategies and coming up with the tools and technologies, as well as using the tools and technologies for them, that's what data engineering does.
Even does some sense of like, so when people access the data, right? Obviously, ensuring that the data doesn't get corrupted over a period of time, is that also part of your job description as well?
So in a way, we don't really give the data. I mean, we give only the read access to people. Okay, no one will have the access to write to a table other than the admins, you can say, or rather the primary developers on it. So we are very, very careful that way to make sure that that does not happen. The concept overall comes in data governance. Who will have the access to read? Who will have the access to modify and so on? And especially when you have like around 500 people reading the same data, you want to be really, really careful. And at the same time, we cannot allow entirety of the data to be seen by everyone, right? There is sensitive data. It once again becomes the responsibility of the data engineer to mask that data, right? We use algorithms and encryptions to make sure that usernames, email IDs, even if he's an analyst, the analyst cannot know whose data he's checking, right?
Okay.
It becomes an anonymous streaming service or so on as such. So yeah.
Okay. So yeah, I think you pretty much explained about what your role is. So this is where probably I want to understand where. Okay, so this is a role of a data engineer. So now, what's the role, or what's the difference between a role of a data analyst, a software engineer, and a data scientist? So if you can just give a sort of what is different between each of these roles.
Let's maybe talk first about the data roles, right, that you mentioned, which is of data engineer, analyst, and scientist, and then maybe look at the software engineer side. So let's keep that.
Okay.
So it's the different questions that you ask and who is best suited to answer these questions, which would maybe give you a better idea about how the roles are defined. If I were to ask tomorrow, where is this data coming from? Is it good data? Is it bad data? I have like terabytes or petabytes of data, and I need to store this. At the same time, I have a team who wants to use that data, but they're facing issues accessing the data. The only person who can answer this question is a data engineer.
Okay.
But if now another person asks a question, hey, you have this amount of data. Can you tell me? I basically want to find the gross revenue of this particular product or a time period of this. Can you tell me which would be the best fields which are suited for this? A data engineer cannot answer your question because he does not have the business understanding. He may have the domain knowledge, right? But he won't have the business understanding. That's where a data analyst comes into the picture. He will know exactly what the financial terms are, right? If you want a year-on-year analysis, he'll know exactly how to manipulate those fields. He will definitely be in correspondence with the data engineer saying that, hey, buddy, I want a field, and this is the field, what it does. Can you tell me which would be the best suited field from your data dictionary, right? Your like fields that you have. So data engineer can maybe respond in that way, provided he gets that help from the data analyst. But it's the data analyst who'll answer your business questions.
Okay.
Now you want to say tomorrow that, hey, that's good. So a data analyst can, create graphs for me. He can create all kinds of revenue graphs and stuff. That's great. But my next requirement is that we are a supply chain company, and tomorrow the whole concept is that we have a store which is in US and we work out of India. And we want to know how much amount of goods to send to US after 6 months. Because it takes 6 months to reach US. I'm just giving an arbitrary example. So we have to plan right now, right? Because if we do not plan right now and we sell only 400 goods, but at that time the sales spiked, then we won't be able to sell. It's a loss for the company, right? Who's going to make this decision of all that, right? Or who's going to predict it? You have to basically predict based on past factors and stuff. That is where a data scientist comes in.
Okay.
He'll work in tandem with the data analyst, because data analyst will have more of the business knowledge, but the data scientist will be very much knowledgeable about stats, even data analyst, but he'll know more about your models, predictive analytics and everything. So everything into the future, so as to say, or else to predict the prices, what the good should be selling at certain periods of time, like Christmas season or so on. That's what he'll do.
Okay.
So that's a data scientist. Now I guess you understand the role between the data engineer. So now, but let's go to the software engineering side. Are all of these software engineers? You can say definitely they kind of are, but at the same time, it's about the code domain that they relate with, right? Once again, as software engineers itself is a very huge, it's a very big term, so as to say, right? Because earlier everything was software, so you thought of it as that. I think that's where they came into it. Rather than the term application engineering and so on. But right now, if you look at it, you have the front-end engineer, you have the back-end engineer, right? You have a Java developer in back-end, or you have Python developer and so on. Generally, they create your servers or clients that come up, which will be addressing your requests, API requests, and all that stuff. But in terms of data engineering, they would know enough of data engineering, but at the same time, there would be certain niches of data engineering or certain things of data engineering which a data engineer would be better at it. Right? We have seen multiple. I have seen multiple software engineers who are really great software engineers, but then once they transition over here, they find it to be a bit difficult, and there is a learning curve involved. And it goes the other way too. There are data engineers who do know backend engineering who have gone there, and there are people who know both properly. At the same time, it's your choice how you go here and which excites you, so as to say. What excites you, and so
So, Pradeep, just before we move ahead, I just want to ask, you talked about data packets which are synchronized, which are segregated according to different fields, and those data are encrypted in such a way that even a data analyst doesn't know. I want to go a bit more deep on this perspective, wherein what kind of scripting language do you use for this particular task, and how is the segregation actually happening? And those databases, what kind of databases are normally that you use? Is it an open source databases or a proprietary one? And what are the difference between them? Like, how do you actually make sure that those tasks are automated and your work gets reduced as much as possible?
That's a pretty big question. Let me try to answer it in parts. So as to say, the first question that was asked was regarding encryption of the data, right? So when we do encrypt the data, of course, first thing is the access to the data, right? Who can see the data and who cannot? That's a whole other thing. I mean, when we create the table, we can grant accesses to specific teams and all that. There's based on the email IDs that's been generated via something lists and so on. Once you're part of a certain security group, so as to say, then you can definitely check it out, right? It all comes from the networking aspects. You have different teams who do handle it in like established companies. In startups, definitely you'll have to be a bit more careful because since everything is new, then you yourself will have to get into it, check in, and all that. But even if it's a startup, you can create like a separate VPC, which is nothing but a virtual private cloud inside your AWS or so. AWS is one of the cloud providers. And so you can make sure that only certain IP addresses as such can access it and so on. Once again, it's all about network protocol and network security. So there's like a separate engineering, it's a separate engineering field who will be doing that, right? At the same time, that's that. It also makes sure that only the employees of the company can see the particular data and so on, right? But now let's see the employees do see the data. Next comes is what kind of employees should see it, what team should see it, and so on. So there'll be a different kind of a network protocol over there or security protocol over there. The next thing is, okay, fine, they do get the data, but then should they see all the fields or should they not? That is where a data engineer's responsibility comes in, right? If, for example, if it is something like, a fintech company and you have like account numbers, right? Account number becomes your unique identifier for any kind of analysis. You want to know the number of accounts that have done that. And now the account number will also have your person's name, person's address, person's phone number. It will be highly unethical for a data engineer to not mask this, right? Because then anyone who uses this data further on can directly know what that person's address is. And that is a huge security risk. Tomorrow, if that data somehow gets leaked, then n number of people's addresses will be leaked to the world. So that is where you mask it. How do you mask it? There are like simple encryptions that are then almost every language. It can be SQL, Python, or Java. You have an MD5 encryption. You can just hash it, right? It's an algorithm which takes in a particular input and it gives you gibberish out of it, and there is no way you can solve for it basically. So these are the ways that encryption is different from hashing. In encryption, there will be a key where you can reverse engineer it and so on. So, for example, password is encrypted so that when you do enter your password and you send it across, it is gibberish, but then only the company will have the key so that they can reverse it and get it back, right? Whereas over here, we are basically trying to get a random hash so that no matter what, no one can see it, even if they reverse it, right? It's lost data, basically. But that's fine because the analysts just want numerics, right? Like there was this user because they want to get insights out of it. How many customers are from a region and so on, right? So that's where the data engineering responsibility comes into the picture. And regarding the tech stacks for data engineering itself, Python is the most. It depends on what company wants, or rather, what the priority of the company is. As your data scales and it grows, companies tend to move over to Scala because the most popular tech stack right now for data processing is Spark, Apache Spark. And Spark is built on a language called a Scala. But Spark can also work with Java, Python too. But then since the framework is built in Scala, if you write your code in Python and you give it to Spark, then it has to do some kind of a translation, right? To read from one language to the other. So you won't be able to unlock the complete potential of that framework. So if you want to unlock, so it works for a certain amount of data, but then as the data scales, companies switch over to Scala. So you're basically talking to the framework in its own language, right? And now you can fine tune the parameters, you can put in your own functions and all that in such a way that it actually manages that huge scale of data. And to schedule it, there are multiple schedulers out there in the industry. The most popular is Airflow right now. Everyone uses Airflow for scheduling their jobs and so on. You have a lot of parameters that you can set up sensors in such a way that if you can put a dependency on some other things, and that dependency can be anything. It can be just an API call. It can be that if a new file comes into the system, only then run the entire pipeline or not. So it's very, very flexible that way. At the same time, Airflow is open source, but there is like a paid really good version of Airflow, right? So when we say open source, what it is, it's just that a particular group of developers built something. They knew it was good. They released a white paper on it, or so they released it to the public, and they gave it out for free. But then they know that there are like shortcomings to it, so they started building much more better versions. But now they're saying either pay for this, right? That's the proprietary licensed one, or else you can go for the open source. But if you go for the open source, there might be bugs in it, there might be issues with it, there might be things that are not accounted for. If companies which have a really good engineering team, which are giants, generally go for open source because they do have an engineering team which will handle for all that. New companies which want a faster go to market, right? They want it released immediately. They don't have the resources, or rather, they find it to be more profitable to give money to a third company to buy that proprietary software. Go for that. So it all depends on the company's priorities and such, right? So yeah.
Can you say it's also about like turnaround time as well? Obviously, with, as you said, with the open source, the company itself has to invest more resources to actually make it suitable for their purpose and their application, as opposed to obviously with startups, they're looking at faster turnaround times, so they prefer more specialized applications.
Yeah, exactly. It depends on the time.
Okay, so I mean, having discussed all this, so basically, Pradeep, can you give us a rundown in terms of what a data engineer? Obviously, you've described what a data engineer does and how he fits into the whole pipeline. Also, give us a bit of an insight into how these data engineers work with data analysts, data scientists, and software engineers in your experience, at least.
So we do work with software engineers too. It becomes a whole pipeline because our data is coming from software engineers who do build the backend and stuff. At the same time, your entirety of your Spotify, right? When you do Smart Shuffle, you get recommendations based on the music that. So let's take Spotify as a general example right now at this point, right?
Yeah.
When you start the Smart Shuffle, you basically get music which is not in your list, but it's similar to your list, and you really do you agree with it, right? Now, there will be a software engineer who builds that particular service, but he needs to interact with the data scientist who will build that model for him.
Okay.
And the data scientist will build the model based on the data analyst's business requirements. And the data analyst will give the data to the data scientist from the data engineer. But the data engineer will get the data again from the software engineer. So it becomes
okay. So it's a whole like a feedback loop. You constantly work with each other. Okay.
This is a very small use case where everyone's involved. Sometimes it may not be the case. For example, if it's a completely analytic use case for business, it just goes single direction, right? The software engineer from the app, the data gets generated, it comes to the entire pipeline of Clickstream or so on, and then from there it goes to an analyst. The analyst builds a board and it goes to the management, and you're done. So basically, to know how many users have subscribed this month compared to last month, and the management has to do some key decisions in marketing if they want to change the marketing strategy or so, right? Yeah.
I mean, particularly, this is there, but particularly, especially in fintech, right? So obviously with fintech, you're dealing with more finances and these kind of things as well, right? So especially with these at that level, even if you're a data engineer, is domain specific knowledge regarding finance essential, or is it not really required?
Pradeep, 1 second. Before you answer this question, Spotify, if you're listening this, we have mentioned Spotify at least 3 to 4 times. Just make sure that you put us in Spotify originals. So by next year, at least we can be among those top 10 or 20 Spotify originals. Okay. Thank you, Pradeep. Spotify original, Jai Ho. Pradeep, please answer the question.
Right. So yeah, that's what I mean. Technical skill set is one aspect of hiring when people do hire for new engineers, but then having domain knowledge matters a lot. Once you enter a new domain, you need at least 3 to 4 months to get used to that domain. So it's simple. You have like simple abbreviations. The way the analysts treat the data, the way they think of data, everything is different compared from domain to domain. So especially in the finance, TAT is a very frequent turnaround time, right? It's very frequent. It took me a month to understand TAT is turnaround time. Just give an example. Along with that, leads is lead means nothing, but it's basically a potential for a user to get onboarded to that financial company. So they call it a lead, right? You're pursuing the lead and so on. It took me 15 days to understand that's what a lead, basically a new user, right?
Yeah.
I mean, these are very small scenarios, but of course, at the same time, when you're talking about finance, right? What risk is, what credit is, and how are they related to each other? There will be multiple domains of,
Hmm.
or rather, verticals will work on this
Hmm.
analyst,
Hmm.
but generally, it'll be a single data engineering team, and that data engineering
Okay.
team have to know all of it. So,
Okay.
domain
Okay.
knowledge is very much important.
Okay. Okay, so yeah, this sort of like actually with regard to with especially with regard to data engineering, right? So I was actually looking at a couple of Reddit chats and kind of things to understand in terms of how people get into this field of data engineering. So one of the things that I commonly so obviously there are courses for data analysts, there are courses for data scientists, there are obviously courses for software engineering as well. So you don't, at least I have not come across courses that directly deal with data engineering per se. So do you like in terms of like I mean, first of all, why is that in general? Like, why do you think that is? And plus, do you think having that sort of like a structured course would it actually help benefit you in any way?
I mean, there are courses out there in Udemy for it.
Okay, okay,
It is definitely there. I myself have gone through it. But at
okay.
the same time, I feel, at least in data engineering, no one hires freshers for data engineering.
Yes, 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 yeah, yeah.
Always minimum 2 years, right? One and a
Okay.
half, 2 years, and then they take them in because there are certain expectations. Uh, for example, SQL is very simple, but then to understand the complexity of the data and solve it with SQL, it requires a bit of experience over there in SQL itself only, which generally the freshers will not have, right?
Okay. Okay.
And at the same time, the requirement for a data engineer is very less compared to a Java developer or Python developer backend. So a company is more interested to invest in a fresher in that field
Hmm.
as a Java
Hmm.
developer and train them over there rather than train them over here. I'm talking about in
Okay.
product companies.
Okay. Okay.
When it comes to your MNCs and all that, they on the other hand, they hire freshers as like all the same case
Yeah.
and put them into different domains like data engineering, back end, front end equally.
Hmm.
So as far as I have seen, I have never actually met a person who
Okay.
has been directly recruited as a data engineer from college.
Okay, okay. So you mean to say that initial scale up that you actually need, the initial learning curve is pretty steep for okay, okay. So that's probably
It's not
why
like it's pretty steep, but it's
yeah.
yeah, it's just a bit different from the traditional sense, right? I mean, if it's back end, front end, they're like so similar that generally
Hmm.
people go that pathway itself only. And if you look at it, for every 10 back end, front end folks, you need only one data or two data engineers.
Okay,
That's how
okay,
it goes.
okay, okay,
So,
okay. Yeah, even as you correctly mentioned, I think even I saw this on Reddit where they were telling me about okay, most roles that they advertise for data engineers at least require about 2 to 5 years of initial experience. Even they don't. There are no sort of entry level positions that are generally out there. Even though there are probably very few of them and probably very sought after as well. So yeah.
But having adding to what Tejas said, I remember just when I finished off my engineering, I had went to one of my uncles. So I asked him. I had done a good research on what is a data analyst, what is it, data engineering, and everything. And I said like I'm planning to go there. So I was told don't go there because it's a very stagnant job. It's a very there's a lot of stagnation. You might not grow up. You might just get stuck in mid-level management maximum. You cannot come down. You cannot go up because your domain remains fixed up. Do you agree to that fact that this happens? And is this also the reason why, as Tejas mentioned, the number of courses or number of people who actually want to do data engineering is quite low?
that might be the case too, even though I don't agree with it completely. But if you look at an example, let's say someone takes up backend, right? He's easily able to transition to front end, eventually becoming a full stack, right? And then if that person wants to get into ML, he can easily get into ML, not as a data science. There's a difference between, again, once again, data science ML and
Yeah.
as a backend ML, right? He'll not be training any models. It's just that he'll be a good guy to take the model and use it. Like just as we took the Spotify example of
Hmm.
Smart Shuffle,
Hmm.
engineer did that. He has to be very much in tune with ML is. So you have a lot of free way to swim around with that singular role of being a software engineer, so as to say. But when you come into like data engineering, you are basically stuck with a single vertical, right? You're specializing yourself, so as to say. You go with data analysis. Once again, from data analyst, people do translate to data scientist, right? Because once again, you have the business domain. It's the technical skill set that you have to take up. That's all, and you're sorted with. But other than that, you cannot get into front end or back end easily as such because you're basically specialized. But once again, is it stagnant or not? I believe it's all dependent on the individual, so as to say, because as you go up the ladder, the opportunity definitely decreases across the board, so as to say. But the use case is just this, that the number of people who come up saying that we want a new website is more compared to the number of people who come up saying that we want a new database. That's all.
Yeah, that's what I agree to that, because see, that's the main agenda of it. We can have probably in the future we can have a session with you and fellow college students that we are tied up with, wherein you can tell them what exactly is the proposition of being a data engineer and what is the future of it. You can help us guide them better. That is probably something that me and Tejas are very keen on. To making sure that kids now who are just getting out of engineering or doing engineering, not just engineering, any other degree for that matter, know what they are stepping into rather than just seeing it on Instagram and advertisements and stuff. So sure, pretty sure that is going to happen soon. That is still planning, truthfully seeing, but yeah, sure, that we'll look into it. Having said this, coming back to our topic. So as you said, a data analyst is someone who you make sure, a data engineer makes sure that whatever data is irrelevant to a data analyst, you mask them. That becomes your moral ethics, that becomes your regulations and stuff. So I want to talk about regulations here now. Let's go into regulations. There are a lot of such regulation across different countries across the globe, wherein these regulations have to be followed. Can you give us a brief on this? For example, if you go with GDPR, that is of Europe Union, they have a set of rules and regulations that any particular industry that collects data from any medium, they have to go through this particular regulation. Can you just give us a brief of this?
Sure. I mean, it depends on where your company is based out of and what region's data you're handling and so on. But then every region will have its own laws of the land that you have to follow to be compliant with it. For example, you have the GDPR for I think Europe and then for the US too. Basically, it says how you should handle the data, right? Generally, the privacy data, personal data, and so on, for how long you can keep the data. And there are certain laws for how you should handle the data itself only. How you can store the data. Basically, there are certain encryption protocols that have to be followed, security protocols that have to be followed for such and all that. When it comes to India, I mean, it's all varied, and we all know about the new law that came in last year in 2023, right? I think it was the DPDP Act that came forward. So yeah, PDP. I mean, it's sorry.
PDP, Privacy Data Protection.
Is it? Okay. Isn't it the Digital Personal Data Protection, DPD?
To my research, PDP, Privacy Data Protection.
Okay, sure.
PDP comes under a pact of it.
Okay. Yeah. So yeah, I mean, it's a welcoming move. It's a new one that's come to India as such. So anything that's new will have its own shortcomings, which will have its own, and there is room to grow, and so it will. But it's a good thing that now there is something which will regulate your personal data, where you do have a say as to whether you want to delete your data from the database of such organizations. And of course, there will be a watchdog which will regulate it and keep monitoring the situation and take necessary action if it's not been and it's not been followed or so on, right?
But from a company perspective, if I can ask, for example, if for example, let's go with Twitter, right? Twitter is not a not a India-based company. It's a US-based company. Its functioning is happening in India. right? So according to the rule, according to the regulation, it says that the data collection or the data of Indians should be inside India, should not be exported to any other countries for that matter, with respect to data collection and data engineering. Do you think
Once
it
again, I
actually
think there's
matters?
some kind of, I think there's some kind of a confusion over here. If I'm not wrong, the entailment is to store the data in India within Indian servers, right? So as to say, it does not mean that the data cannot be used outside India. It can be easily, queried, and you can have analytics out of that. And it can be it's just that the majority of data has to be inside India, stored in Indian servers. It does not mean that it cannot be used outside. One of the
Uh,
main reasons why countries may ask this is that tomorrow, sorry, uh,
yeah,
one
please
of the
go.
main reasons countries may ask this is that tomorrow, if someone were to get hold of the data as it is, right, the raw form, so as to say, no one, everything, as long as you master data and you're using it only for analytics and insights, I think you can use it outside the country as long as you mask it, right?
I sort of agree with
But
I sort of agree with what Pradeep is saying, because even I think even from what I've heard, it's basically that data should be stored at, for example, in the host country servers, as opposed to, I think access of data is unlimited, because if there's no access, then man, it's kind of like it's impractical for a company that's based outside that host country. For them to have any sort of analytics without accessing the data, it's impossible. So I agree with that. I think the probably the regulation states that the data has to be stored at the host country's servers. I think that's probably what the regulation is saying.
Yeah, I think it was my bad. But yeah, I got a view on the regulations. But are you is most of
So
those from a user perspective, it's great that our data will be protected, and government is doing something with respect to
so
IT. I want to ask this question to Pradeep, if it's fine. I wanted to know more about, if you can give me a brief on real time data. How does that work? What is the overall concept behind it?
sure, sure. In data itself, you have two kinds, right? You have the batch data processing and the real time. Batch means basically you wait for a certain amount of time for data to get accumulated, and then at once you run it, right? It can be daily batch intervals or hourly. You basically, to give it in a layman's term, think of it, there is a service which adds data to a file, right, continuously, and you wait for an hour basically before you then process it, right? You run a single job to process and you're done. But now, if your stakeholders, so as to your consumers, bring up a question that they actually do not, specifically in fintech, they want to know things as is right now, right? And they say that at the max, we can have a 5 minute delay. That is where you'll have to build a pipeline which can process the data at real time and take it forward, right? When we say real time, there is definitely nothing which does it at real time. It's always near real time. There will be some delay with the processing. It's just that it's very, very close to real time. That's all, right? How that basically works is basically you'll have a pub sub. It's called a publisher and a subscriber kind of a model. You have one particular pub sub. It can be things like Kafka, or you have the Google pub sub and so on. So it will be a streaming service which will have a listener which will continuously listen to events that are getting generated. The event where it's getting generated, we call them as producers. The producers can be a website, it can be an IoT sensor, it can be anything, right? In the case of Spotify, it was an application, so as to say. It continuously listens for this, and as in it creates things called as like topics. You can think of it like subsections for unique domains, right? And as in when something new comes over here, it sends it to a subscriber. Why is a subscriber important? Because that topic can have multiple subscribers. So you can now create like multiple pathways of real time, right? You don't have to be like, hey, I can only give the data to one person. No, I can give the data to simultaneous people at the same time, right? As and when it comes. And it has a lot of fallback protocols that if by chance a subscriber misses to get the data, they can again get the data once again. So you have concepts like idempotency, which basically this that no matter how many times the data runs, you should always get the same outcome, right? Which is very important in like classical systems and real-time systems. You basically don't want your streaming service to send the same data twice, thinking that the data didn't go, but you had like half of the data over there. So right, so just so to say. So now it can, that is just fetching the data, but now you have to do real-time processing of the data, right? You want to do some kind of a transformation on it, basically processing of the data. And so once again, Spark comes into the picture, or you have services like Flink, Apache Beam, Apache Spark, as I mentioned, wherein you can build a streaming service, basically a server which becomes a subscriber. It listens to that particular message, let's call it a message which comes in, it takes it in and it processes the message, right, and gives it out to a particular table. It can write to a table or a file. That table, at a refresh of like 5 minutes, keeps a Tableau service reads from that table and generates a report. So your report is basically at real near time, right? Almost real time data that comes, right? At the same time, it may not be just a report. It can once again go back to the producer, and you can maybe have a backend team which will be basically showing like music that's being played right now, right? Yes.
Yeah. I mean, yeah, with especially, I think as you mentioned, one aspect of fintech. This is what I've read about and stuff. So especially with in the case of foreign exchange and forex, right? Obviously, like when people are trading with at such large volumes, their latency that they want is they want low latencies. So obviously, as soon as the currency value changes, they want to know how it changes and if they can sell at that period of time. You're talking about a couple of seconds, milliseconds in some cases. I even like saw this couple of documentaries on I think Discovery was talking about how some companies have set up direct fiber optic cables directly from, say, you have these trading houses, and they have direct fiber optic cables that supply data, and then they're basically paid services sometimes as well, depending on how fast you want the data to be supplied to you. Is again as a paid service, as you mentioned. So yeah, pretty fascinating with what you can do with just reducing latency of your data acquisition. It could make such a big difference. So yeah,
it's all about the cost that's being it's basically whether the insight that gets generated, right, because of this is offsetting the cost,
yeah,
right?
yeah.
Whether you can generate that much value by, because having a real-time system is costly, it's not cheap. But then if you have a lot of data and if your interval is at 15 minutes, you're running it again and again, it might as well be better to have it real time also.
Yeah,
so
yeah. Pramod, did you want to ask something?
So, Pradeep, as you said, data engineering, to my best of knowledge, data engineering is different for different sectors, right? For social media, it's different. For fintechs, it's different. How do you, can you help us or guide us on different types of engineering, how it is, and does it depend on different not IT, different industry standards?
I mean, whenever you change the domain, once again, it's expected that how you work upon will change. It's just that it's not like a different kind of data engineering. It's just that the considerations that you take enforces your tasks that you do, right? For example, if you're working for a fintech, it's going to be highly much of a hustle because nothing is ever planned. And in fintech, everything has to happen as is, right? I mean, you want to have it as soon as possible because the better your business intelligence is, the better financial decisions you can make at the end of the day. So once again, the hustle is real. And now one of the most important things in fintech is the business intelligence unit, right? As it says, it gives you the intelligence, it empowers the management to make the right decisions at the right time. So you can just so if you're part of that, then you will need a data engineer in such kind of a unit who can provide the data to all the analysts and all the data scientists. But his job is not to maintain the data. His job is to fetch the data. So he's a data engineer, definitely, but he's more of a consumer of the main data platform, right? He's trying to get the right data to give to his analysts. So once again, his day-to-day roles will be different compared to the data engineer who's working on the platform itself only.
Okay.
Here he's working with getting latest tools and tech stacks and making sure that the right data is out there, transforming it. For example, whenever you build models, generally they want signals or so on, right? I'm not that well versed with ML, but generally with machine learning models and so on, whenever you have a continuous state of data, right? Like let's say numbers from 0 to 100, they don't want it as numbers from 0 to 100, rather they want it as buckets. You put into quartiles or something as such, 0 to 25 is bucket 1, bucket 2, bucket 3, bucket 4. That becomes like a signal. You're basically creating a classification which the model can better understand and give you output for. Now the question is, who's going to do the speech engineering? Who's going to make sure that the data is put into buckets and you have a new column and all that? That's why the data engineer generally of that team comes into the play and he'll be doing all this, right? So he's not managing huge amounts of data, but he's enabling the other people to do it. That's one kind of data engineering. The other one is basically the person this data engineer is consuming data from, it's coming from another team, which will be like the warehouse team, platform team, where they're basically managing tons of data per day, right? Like, I mean, maybe terabytes of data or petabytes of data, so on. So they will have different considerations because they are not dealing directly with ML engineers, so as to say, but they have huge amounts of data. So they will be proficient in other aspects of data engineering compared to the first guy. So a different type of data engineering comes in. And once again, as your domain changes, sometimes few tools work better in certain domains and few tools work better in other types of domain. So in data itself, you have the big data tech stack and the normal data, let's say tech stack, right, which is the RDBMS or relational database management system, traditional warehouses and so on. In big data, you don't really have like kind of tables. We work a lot with files and all. We do create tables like metadata of tables, which we use as a structure. But generally, it's very, very flexible over there. But it becomes very much of a pain for the analyst to get the analysis on. They generally want it in a tabular structure. So the BIU will generally work with like your traditional tools, whereas big data folks will generally work with your Spark and everything. So,
as you said, as the domain changes, tool changes. Correct, right? So I am currently as a database administrator. So if my skill set is with MariaDB, MongoDB, and those kind of things, I can change my company. I can move on to some other company, and I'll be still working on MariaDB or MongoDB or some other open source or proprietary databases. Having said that, when it comes to your domain, right, you're currently working under travel section. Am I correct? Am I wrong?
right.
Yes. So your particular industry is under a travel section. So is it possible that and a fintech data engineer can come into your domain and start working, or you can move on to the next some other company which is a fintech company, or do you have to stick to this industry itself?
Nothing as such. The industry specific does become a consideration because it kind of helps you to better onboard to the new company at a faster rate. That's about it. It would be a consideration for like a business analyst or like a data scientist because they work very much into the business knowledge. It's involved in the day-to-day activities. But as a data engineer, of course, it is something to consider, but it doesn't become like your majority of what they will be looking for. Because at the end of the day, you're just dealing with the fact that are you able to handle data? Are you able to handle big data? What are tool sets do you know? And whether the tool sets that you do know, are we able to accommodate that? So
okay. Thanks, man. That was very clear cut. That also answers the question of stagnation also.
One thing is for sure though, if data is the thing that you like, once you come into data as a domain that you're getting into, or rather the subdomain that you're getting into, then definitely I can give you a pathway whether data engineering is the right one or the data analyst or the data scientist one, right? Because there's a clear cut difference. If you're someone who enjoys being responsible for things, right, where numerous number of people are going to come to you asking for stuff, and you want to assure data quality to the maximum, which means that if there is something wrong, you have to spend maybe a day or two or maybe three looking around billions of rows, records, code just to get that one error, right? And it is very frustrating, honestly, at times. But you are doing it because you love it, and that's a different thing altogether, right? And you love to code specifically. You love to learn new things, so as to say, when it comes to tech stacks. I'm not just saying that, learn just X, but rather you're learning a new tech stack altogether because data engineering is changing so much that every 4 years you have a new tech stack that's coming up. Of course, the base remains the same, like language, Scala, Python, but then what you're doing with it changes a lot. Spark, which was 3 years back, is not the same right now, right? So it's not just you're adding something, you're basically discarding what you knew and you're just starting over again with the fundamentals being the same, obviously, right? Then data engineering will be for you. As a data analyst, once again, there's nothing like less of this, but if you're more into the business side, right? You're less into the coding part. You hate coding, so as to say, you're good with SQL, you're good with bringing up reports, you're good with like maybe fundamental Python so that you can do data exploration and all that, but you hate the coding part of it, of like building a framework and all that. Then data analyst definitely might be something that you would be much better to shine off on. I know people who are really, really bad at Python, but they're amazing data analysts, right? Because you have the same skill that you are willing to go deep into the data to find where the error is, right? It's a simple thing. They create their dashboards. The business intuition says that your number or KPI, key performance indicator, should be something around like 50%, but the dashboard shows 30%. Now spend 1 week finding out why it's 30%. You don't have to code, you have to write SQL statement, go through every data, find where you did wrong, whether your understanding is wrong, talk to like 10 other seniors who may have better understanding to see where your understanding differed, right? But once again, you're looking more into the business perspective of the business understanding of what it means. The data is there, you're not correcting the data. You're just trying to see where your understanding changed. And if your understanding is correct, the data is wrong, you just tell the data engineer, hey, buddy, this is wrong. Then he'll do the rest. He'll do the coding part and refigure out everything. But your job is, as a data analyst, generally that's what you will do, right? If that's the case, that's suited for you. Going a further ahead, you hate coding, right? You like business, but at the same time, you're really, really, really good with statistics, and are interested with like model training, how data goes and how the predicting and all that happens, right? How do you predict outflow and all that? Then machine learning would be for you too. But the whole fact is, each one of them has a different learning curve. At the base, all of them love to get deep into data, which is basically they're good problem solvers, right? Without being a problem solver, it's a generic baseline. But at the same time, as a data scientist, you have to know exactly more about the models. You have to know more about statistics, right? You have to know more about the maths behind it. And really good machine learning engineers don't really just look at the model as it is. They understand how the model works to properly tune it and so on. So you will have business knowledge, at the same time you'll have statistics, and even not like you're using coding to use that statistics, but it's very minimal coding too.
I just want to say, like, obviously now with the amount of data collection that's happening, not just in your fields, I would say, like I'd say even in, for example, in mechanical engineering, you have a lot of in situ monitoring systems that monitor stuff real time. So you have a lot of data that's being collected. So in some sense, could you think that all of us are in some sense data, like engineers using data, or somewhat data engineers in some way?
Yeah, I mean,
No, okay. I mean, like, more so in the sense, it's more like obviously with all of us generating data so much. With, say, for example, as a mechanical engineer, just knowing mechanical engineering is not enough, especially now. You obviously have to understand how that data is being generated, how it can be sort of analyzed, and these kind of things. So that becomes you become a full complete engineer, knowing that side of things as well, as opposed to just understanding the mechanical concept things.
I mean, data is everywhere. That's true. But the reason why the field itself evolved is that there was a reason that they needed people who could manage data at scale. The at scale part is where differentiates a data engineer from someone who can handle data. Because even before data engineering came into play, you had software engineers who were doing that. So what was the necessity to have data engineers? Why would big tech companies invest so much into having good data engineers, right? They could have easily used the same resources that they already have, put them into data engineering and said, hey, get it done. But then the whole thing is this, that when the data scales up, your existing systems are just not able to handle it. Your single computer cannot handle that amount of data. You need a distributed system which would do that. So that's where, I mean, definitely. So for example, banks and financial institutions, I think even now, or maybe even like 5 years back, everything was done by Excel. You won't believe it. Everything was done by a CSV or Excel files. So aircrafts, right? Your in terms of, I mean, I'm not talking about data engineering, but generally your aviation sector and your banks and few other sectors like maybe defense or so on are one of the most slowest sectors to adopt new change. They don't. They never do. Reason being, something new means it has something which is deficient. It is something that's not been tested properly, and people can hijack it or hack it, right? So, and there are few sensitive sectors where you just cannot afford. One of them is finance.
Yeah.
Right. A fintech is different from a bank. A fintech is where they just want to make money. A bank is somewhere where they store money, where people's livelihood.
True.
And most banks run on very, very old and traditional servers and setups and tools. They don't update that.
It's probably, as you said, it's because people want more robust systems, right? They obviously rely on those robust systems, which has worked for generations. They were, before someone switches onto something new, they want to make sure, they want to do sort of years of testing before they actually before they implement it.
So the only way to get data is basically take an extract of that days, and you'd have like Excel files, banks. I mean, I was working for a finance company which had actually taken over another company which exists for 20 years or so on, and they were working with Excel files. I mean, that's basically a manager sending an Excel file to his senior manager on a daily basis saying, "Hey buddy, look, this is our daily reports." Right? So it worked because the data was not at scale, right? And they would have like separate files for separate locations and so on. But then if the data did scale up, they would be in a huge trouble because your computer cannot handle that much amount of data.
Yeah. But yeah, I think with that, I think both of us, me and Pramod, have learned a lot from this conversation. I think we have a lot more respect and a lot more sort of understanding about what a data engineer does. Obviously, you're pretty much hidden away at the back end from compared to data analysts and software engineers who are generally in the front, who are generally out in the public and talking about these things. But it's great to know that like even data engineers sort of are the critical key element for all this to happen as well. So thanks, Pradeep, for coming on to the podcast and just talking about this. It was great having a conversation with you. So yeah.
Yeah, same here, man. It's been a pleasure talking about this field. At the same time, it's not every day you get to talk about something that you do love. So it's been really, really great. I mean, I'm really grateful for this question. So,
you're among those rare gems who actually love their job.
Yeah. says the guy. You're watching a guy who apparently does not like his job so much now.
Hey, please. I have a lot of followers in the company. Terry Road, I love you.
that's the whole, I mean, even with interviews and stuff, right? When you really do love what you do, when you take interviews for candidates and all that, the entire chemistry between the interviewer and the person who's getting interviewed, it just changes. You just end up having a really hearty conversation, right? I mean, that showcases a lot. So yeah.